You know what? One of the most effective ways to prepare for exams is to practice taking past versions. This helps you to get used to the format of questions, and if you time yourself, can also be good practice for making sure you spend the right amount of time on each section. If you want to know more about it, please join me, myself Abhisha, your tutor for the day. You are watching Crack Easy, the place to learn how to crack easy exams. Please don't forget to subscribe the channel. In this particular session, we are going to solve GATE 2006 and 2007 questions on Fourier transform. So, let's get started. The first question I have for you is from GATE 2006. Let x of t, x of j omega be the Fourier transform pairs. The Fourier transform of the signal x of phi t minus 3 in terms of x of j omega is given as. Four options are given. Option A, 1 by phi e raised to minus 3j omega by phi x of j omega by phi. Option B, 1 by phi e raised to 3j omega by phi x of j omega by phi. Option C, 1 by phi e raised to minus 3j omega x of j omega by phi. And option D, 1 by phi e raised to j omega 3 x of j omega by phi. Here we have a signal x of t. Its Fourier transform is given as x of j omega. We are asked to find out Fourier transform of x of phi t minus 3 in terms of x of j omega. Got it? Do you know how to solve this question? You might have studied about properties of Fourier transform. In fact, we have to use these properties to find Fourier transform of x of phi t minus 3. The first property we are going to use is scaling property. So, have a look at it. According to this property, if x of j omega is the Fourier transform of x of t, then 1 by mod a x of j omega by a is the Fourier transform of x of at, where a is a constant which is known as scaling factor. Got it? Based on this property, we can write the Fourier transform of x of phi t as 1 by phi x of j omega by phi. Here, the scaling factor is phi. Hope you got it. The next property we are going to use is shifting property. According to this property, if x of t and x of j omega are Fourier transform pairs, then x of t minus t0 and e raised to minus j omega t0 x of j omega are also Fourier transform pairs. In fact, we are asked to find out Fourier transform of x of phi t minus 3, which can be written as x of 5 into t minus 3 by 5. Fourier transform of x of phi t is already found out. So we have to introduce a time shift 3 by 5, and based on this property, we can write the Fourier transform of x of phi t minus 3 as 1 by phi e raised to minus j omega 3 by 5 into x of j omega by 5. Thus, our answer is option A. Hope you all understood this problem perfectly. Let me now take you to next question. It's from GATE 2007. A 5-point sequence x of n is given as x of minus 3 is 1, x of minus 2 is 1, x of minus 1 is 0, x of 0 is 5, and x of 1 is 1. Let x of e raised to j omega denotes the discrete time Fourier transform of x of n. The value of integral minus pi to pi x of e raised to j omega d omega is. Four options are given. Option A 5, option B 10 pi, option C 16 pi, and option D 5 plus j 10 pi. Here we have a discrete time signal x of n. Its Fourier transform is given as x of e raised to j omega. and we are asked to find out the value of integral minus pi to pi x of e raised to j omega d omega. In fact, a discrete time signal x of n can be mathematically expressed in terms of its Fourier transform as x of n is equal to 1 by 2 pi integral minus pi to pi x of e raised to j omega n d omega. Now we are going to substitute n equal to 0 in this expression. Correspondingly, we get x of 0 is equal to 1 by 2 pi integral minus pi to pi x of e raised to j omega n d omega. Or we can write it as 1 by 2 pi integral minus pi to pi x of e raised to j omega d omega. Hope you remember, in the question we are asked to find out the value of integral minus pi to pi x of e raised to j omega d omega. From this expression we can write integral minus pi to pi x of e raised to j omega d omega is equal to 2 pi into x of 0. X of 0 is the value of x of n at n equal to 0 and it is given as 5 in the question. By substituting this value, we get our desired quantity as 10 pi. Got it? Thus, our answer is option B. So, we are at the end of this session. Hope you all enjoyed it. If you have any doubts, please do let me know in the comment section. Thanks for watching. Thank you.